In this lesson we're going to continue to look at Newton's third law. Before we do so, let's just remind us what the law says. And it says this, that for every action there is an equal and opposite reaction. So we've got a woman here standing, and let's say that she has a mass of 60 kilograms. So that means that the force of gravity is pulling down on her, and as a result she's pushing against the earth with a force that is equal to her weight. And we remember that her weight is equal to her mass multiplied by g, which is the gravitational field intensity at the Earth's surface. In this case, we'll just say that g is equal to 10 newtons per kilogram to keep things simple. Alright, so as a result, her weight will be 60 times 10, which will result in a force of 600 newtons pushing against the Earth's surface. So that is what we call the action. We can call this force the action. But at the same time, there is a reaction. That's to say, the Earth pushes back against the woman with an equal but opposite force of 600 newtons. So we can call this is the action, and following Newton's third law, the Earth pushes back with a reaction, and these are equal but opposite. And you say, well, that's fine, that makes sense. We've got a force pushing down and an equal force pushing up. The forces are balanced, the woman's not moving. But what about this situation? Here I've got an object that's moving, a 60 kilogram cannonball. And you'd say, well, surely the forces aren't balanced in this situation, otherwise the cannonball wouldn't be moving. But they are. Again, we have the same force of gravity pushing down on the cannonball. As with the woman, the force putting it downwards is equal to its weight, which is equal to its mass times g, which again is equal to 60 times 10, which results in a force of 600 newtons. So you say, well, that's the action. Clearly, where's the reaction? But there is a reaction. At the same time as the Earth is pulling the cannonball towards it with a force of 600 newtons, the cannonball pulls on the Earth with an equal but opposite force. So we have 600 newtons acting downwards and an equal but opposite force pulling the Earth towards the cannonball. Now, according to Newton's second law, which states that if a force acts on a mass, then it will accelerate. Okay, and the acceleration is proportional to the force that's exerted. Well, this means that the cannonball will accelerate towards the Earth, and at the same time the Earth will accelerate towards the cannonball. And you say, well, surely that's impossible, but it's true, it does. The only difference is in the sizes of the accelerations. Let's just calculate those explicitly. So rearranging Newton's second law, we can say that the acceleration of the cannonball is equal to the force that's acting on it divided by its mass. The force is 600 newtons and the mass is 60 newtons, and so that gives us g, the acceleration due to gravity, which is 10 meters per second squared. Now at the same time, the Earth also accelerates towards the cannonball, and the acceleration of the Earth is equal to the force of the cannonball that's pulling on the Earth, which is 600 newtons. That's this equal but opposite force divided by the mass of the Earth. Okay, and there we have the difference, because the mass of the Earth is 6 times 10 to the 24 kilograms. Then we'll find out that the acceleration of the Earth towards that cannonball is equal to 10 to the minus 21 meters per second squared. Just to give you a picture of that, if you're not familiar with scientific notation, okay, what we're saying is this: that the acceleration of the Earth is equal to 600 newtons divided by 6 and then 24 zeros, kilograms, and that gives us that number of meters per second squared. So this is a very, very, very small number. So to summarize, what Newton's third law says is this, that when the Earth pulls on the cannonball, causing it to accelerate towards its surface, the cannonball pulls back on the Earth with an equal but opposite force, causing the Earth to accelerate towards the cannonball. But of course the difference is in the size of the masses. Because the mass of the Earth is so enormous, its acceleration towards the cannonball can be treated as zero. That's to say, we can say that the Earth doesn't really move. And it's only the cannonball that appears to accelerate.